Hello and welcome to another edition of Math in the Kitchen with Miss Stewart. Hi everyone and welcome to another edition of Math in the Kitchen. Today we're going to be talking about multiplying mixed numbers by whole numbers. Okay, and if you remember from past lessons, remember mixed numbers are those numbers that have a whole number with a fraction. So like the number 1 and 1/2, that's a mixed number. And whole numbers are always those things that are just represented in wholes. There's no parts or pieces to them. So the number 5 is a whole number. The number 1,400 is a whole number. It doesn't have any fractional pieces with it. All right, so let's take a look at some examples today of what we're talking about. Today we're going to be talking about how to multiply 5 times 1 and 1/2. And then another problem we'll be solving is the number 3 3/4 times 2. Now, there are two different ways that I'm going to show you today on how to multiply mixed numbers by fractions. The first method is called the distributive property. Now, by definition, the word distribute or distributive means to give out to all. Okay, so in the distributive property, we're going to be giving each piece the whole number, okay, or the whole. Okay, and then we're going to talk about how we can use the C method to multiply. All right, remember I told you in the last episode that sometimes improper fractions make solving a problem easier? This is that occasion. This is when the C method becomes a valuable tool to have. All right, let's talk about both of these methods. First, we're going to talk about the distributive property and what that looks like in a math problem. So for this problem here, 5 times 1 and 1/2. The distributive property says I have to times the 5 by the 1 and by the 1/2. So what that looks like when I rewrite it would be like this. 5 times 1 is one answer. Then I'm going to do the other piece. 5 times 1/2 is another answer. Now let's solve both of those pieces. 5 times 1 is a math problem we know. 5. And 5 times 1/2, well, think back to episode 1. Episode 1 says whenever I have a whole number times a fraction, I need to put it over top of 1 because anything divided by 1 is itself. This is not changing the value. I'm not making anything up here. Nothing has changed in value. I'm just writing it in a new way so that I can use it in this problem. So 5 over 1 times 1/2, we do our n to n times d to, or over d to d. 5 times 1 is 5, and 1 times 2 is 2. So after I get these two pieces, now I can add these two together, and I get a new answer. 5 plus 5 plus 5 halves equals 5 and 5 halves. That right there, boys and girls, is a possible solution, is a possible answer. But how many of you are sitting there with your pencils in your hand and you're like, but Miss Stewart, that is improper? If that's what you're thinking, you're absolutely right. There's another simplified way to write this problem. But let me pause here for a moment just to say that right there, boys and girls, was the distributive property. That is how you give the 5 to each piece. And this is the solution that we came up with. Now, everything from here on out in the distributive property is just things that we've already learned. This is called the simplifying process. This is not the distributive process. We're done with that. We finished it. Now we're going to simplify this problem. So 5 and 5 halves is one way to write this answer, but let's look at what 5 over 2 represents. Now, some of you like to think through it in your head, and you can say, all right, I have 5. That means I get 2 groups of 2 with 1 left over. So 5 halves is actually equal to 2 1/2. For those of you who think in your head, you're absolutely right. For those of you who need to see it written out, like usually I like to see it written out, I'm going to show you how to solve it written out. Now this 5 wholes here can stay 5 wholes, but this 5 over 2, I'm going to do what I like to call side work. And so I'm going to say, all right, if I have 5 over 2, that means 5 divided by 2. And 5 divided by 2 is 2, and 2 times 2 is 4, and 5 minus 4 is 1. There's nothing else to bring down, so this answer is 2.5. Now, for those of you who thought through it in your head, here's a visual representation of what you thought through. For those of us who needed to see it written out, that's what it is, 2.5. But remember, we're simplifying. There was another piece to this problem or to this answer, and the other piece was 5 wholes. So now we need to take 5 wholes plus 2 1/2 to equal 7 1/2. And that, boys and girls, is how you simplify your answer. So 5 5/2 is an answer, along with the answer 7 1/2. And again, I'm gonna say it so we don't forget. You need to be able to see that both of those answers are the correct answer, because remember, so many times we're asked, what are the 2 correct answers, or what are all of the correct answers? And you should be able to look at solutions and say 5 5/2 along with 7 1/2 are the correct answers for this particular problem. All right, let's take a look at another example using the distributive property. This time I want you to pay attention that the numbers are in a different order. The last problem, I started with the whole number first and then the fraction. And this time I'm starting with the mixed number first and then the whole number. It doesn't change anything. You still have to distribute the whole number to both pieces of the mixed number. So what that's gonna look like is the 2 has to be multiplied by the 3, and the 2 has to be multiplied by the 3/4. So let's take a look at that. 3 times 2 will give me an answer, along with 2 times 3/4 will give me an answer, okay? So let's do our math fact. 3 times 2 or 2 times 3, remember you can flip those around, they mean the same thing. That equals 6. And then 2 times 3/4, wait a minute, I don't wanna do just a 2. I wanna make it easier to use. So I'm gonna say 2/1. I'm gonna rewrite it in a new way, times 3/4. Keep erasing my lines, sorry guys. So now I can do numerator times numerator over denominator times denominator. All right, and so what that equals here is 2 times 3 equals 6, and 1 times 4 equals 4. Okay, so let's add that together. This answer here becomes 6 plus 6/4 is 6 6/4. That is the correct answer. That is the answer when we finish the distributive property. Great answer. However, it's not in simplest form. So let's get it there. I know that 4 can go into 6 one whole time, and then there will be 2 pieces left over. So I know that 6/4 is 1 2/4. But again, those of you who aren't thinking through that mentally just yet, let's look at what that looks like written out. So over here, I'm gonna do my side work. 6 divided by 4 is 1 whole time. And boys and girls, I'm gonna write down the steps. Remember, long division is divide, multiply, subtract, bring down, bring it on back. And our song, divide, multiply, and subtract, bring it on down and bring it on back. So that's what I've done here. I started with division. 6 divided by 4 is 1. Multiply that now. 1 times 4 is 4. 6 minus 4 is 2. There's nothing to bring down, so I don't have to do the bring down step. 2 is my leftover piece. So I get 1 2/4, okay? But remember, there was a 6 over here, 6 wholes, and I have a 1 whole over here now, so add them together. So 6 plus 1 2/4 equals 7 2/4, okay? Now, how many of you are sitting there itching and saying, but Miss Stewart, 2/4 is 1/2? Well, if you're thinking that, you're absolutely right. We did simplify our answer from 6 6/4 to 7 2/4, but we didn't simplify all the way down, because 2/4 could be simpler. It can be written as 1 1/2, but I already know that, so I don't have to do any extra math. I can just rewrite another solution. So this also equals 7 1/2. All right. So this time we were able to get 3 possible answer choices. we said 6 and 6/4, along with 7 and 2/4, along with 7 and 1/2 are all correct and possible choices for this particular problem. All right, let's take a look at these same exact problems, but this time instead of using the distributive property, we're going to use the C method, what we learned last episode. All right, so let's go back to that original problem. 5 times 1 and 1/2. All right, when I'm multiplying by whole numbers, I typically throw it over a 1, right? Because it's easier to have a numerator and a denominator when I'm multiplying. And that's what I'm going for here. I want both of my numbers to have a numerator and a denominator. I don't want any whole numbers. I don't want anything like that getting in the way. I just want fractions, numerators and denominators. So in order to write 5 as a numerator and a denominator, I'm going to say 5 over 1. Now, in order to get this mixed number to have a numerator and a denominator only, I'm going to use the C method. Remember, that starts at the denominator, it circles around here to the numerator. We multiply, then we add. So 2 times 1 is 2, plus 1 is 3. So we're gonna keep that times sign in the middle. We just figured out our new numerator is 3. And then what's gonna be the denominator? Do you remember from last episode? The denominator is going to stay the same. Whatever denominator you started with is the denominator you'll use now. So we're going to keep that 2 as our denominator. Now, look at how beautiful this looks. It's so easy to multiply fractions because remember we use the rule n to n, d to d. So numerator times numerator over denominator times denominator. So 5 times 3 is 15 over 1 times 2 is 2. So one of our possible solutions is 15/2. But again, we typically want to simplify. If your directions ever tell you simplify, this is the step you'll take. We don't want to see 15/2 as a nice, complete answer. We want to see a mixed number as an answer. So all I'm going to do now is long division. Let's do some side work. 15 divided by 2, because remember, a fraction is the representation of division. 15 divided by 2. How many times can 2 go into 1? Well, it can't. So then I just look at the complete number. How many times can 2 go into 15? I'm going to use my math facts, and I remember that 2 times 7 is 14, so it can go 7 times. Because if I try to go 8, I'm going to get to 16, and that's too big. So after we divide, now we multiply. 7 times 2 is 14. We subtract and we get a 1. Now the next step says to bring down, but I don't have anything to bring down, so I have a 1 left over. So I put the 1 over the 2. Now we're completely reduced and brought down. So 15 over 2 and 7 and 1/2 are both possible correct choices. Now, if you can take a look here at our work, you can see that the C method kind of combines steps together and it makes it a little bit more streamlined. So for those of you who like the C method in the last episode, you're gonna probably like the C method this time around because there's not so many little pieces and steps. All right, let's take a look at the last one. Some fun thing that I just realized, both of our solutions to these problems are 7.5. Totally unintentional. Look at numbers working. All right, let's take a look at our last example. 3 3/4 times 2, okay? 3 3/4 times 2. Again, with the C method and with the multiplication of fractions, I just want numbers with numerators and denominators. So in order to get this with just a numerator and just a denominator, using the C method, start at the denominator, circle round, times this part, add this part. 4 times 3 is 12, plus 3 more is 15. 15/4 times, I want a numerator and a denominator. So for this whole number, my numerator is 2, my denominator is 1. Okay, again, I didn't change anything. I just wrote it in a different way so I can use it. Now let's multiply straight across. 15 times 2 will give me 30, n to n, d to d. 4 times 1 is 4. This is a possible solution. 30/4 is a possible solution, but let's break it down and simplify using long division. Our divide, multiply, subtract, bring down, bring back, okay? 30 divided by 4. How many times can 4 go into 3? It can't, so I'm gonna look at how many times can 4 go into 30. Using my multiplication facts, the first one that pops in my head is 4 times 6 is 24. But could it go one more? 4 times 7 is 28. Ooh, that's a little bit closer. How about 4 times 8? That's 32, so too big. I'm gonna stick with the 7. 7 times 4 is 28. When I subtract, I get a 2. There's nothing to bring down, so 2 is my remainder. So 7 2/4 is another possible answer. But again, remember, that's not in the simplest form because that 2/4 we already set up here could also be 1/2. So another possible solution here is 7 1/2. So if we use the C method, here are 3 other choices for us. All right, let's take a moment and pause so we can do a problem together. Okay, let's take a look. This is the problem I'd like for you to do. 8 1/3 times 4, okay? I want you to use the distributive property along with the C method and see what you come up with. All right, based on what I know about this problem, I know that we're probably gonna need a little bit more room here. So I'm gonna erase my little line and I'm gonna drop it down for the distributive property. I want some room to work. So remember, the distributive property tells me that I have to give the 4 to the 8 and the 4 to the 1/3. So when I do that, 4 times 8 equals 32. And 4 times 1/3 gives me 4 times 1 is 4/3. Okay, so my complete answer over here, one of them is 32 4/3. Okay, but not super nice and neat. We don't want to see an improper fraction with a whole number. So that's one choice, but let's reduce it. I'm going to do side work over here. 4 divided by 3. Some of you can do this one in your head. 3 can go into 4 one whole time. 1 times 3 is 3. Subtract, I get a 1. 1 1/3. But don't forget this piece over here. You have to add it to it. 1 1/3 plus 32 equals 33 1/3. And there's your other answer for your distributive property. Now, 1/3 is already in its simplest form, so there's no more reducing like we had to do over here. All right, so there's 2 possible answers using the distributive property. Let's take a look at the C method though. Same problem, 8 1/3 times 4. The C method says I start at the denominator, circle round, multiply, then add. 3 times 8 is 24, plus 1 is 25. Keep that denominator because we still want it in thirds. 25/3 times, now I want a numerator and a denominator, so times 4/1 equals, all right, I've got 25 times 4. Let's think about quarters. I could do side work if I needed to, but when it's 25s, I can skip count by 25. 25, 50, 75, 100. So this equals 100/3. So this is a possible answer, 100/3. However, I want it simplified. I want a mixed number as my solution. So let me try it out. Let me put it right here. Let's go 100 divided by 3. All right, so how many times can 3 go into 1? Well, it can't. So I'm gonna look at now 3 into 10. 3 can go into 10 3 times. 3 times 3 is 9. Subtract, I get a 1. Now, In the previous simplification problems, we haven't been able to bring anything down because there hasn't been any other number left. But this time we can bring down this 0. So now down here I have a 10. My directions say bring it on down and bring it on back. I literally draw an arrow to bring it back. And when I bring it back, I start the process all over again. 10 divided by 3, again, is 3. 3 times 3, we're still completing the process, is 9. 10 minus 9 is 1. Now there's no more to bring down. So 1 is my remainder. And I end up with an answer of 33 1/3. So another possible solution in the C method is 100 thirds or 33 1/3. Boys and girls, lots of things being added together today, lots of really awesome math thinking going on. Feel free to stop and watch this video as many times as you need to. Like, comment, share. If you have any questions, put those in the comments as well. Thank you so much for watching, and we'll see you next time for another edition of Math in the Kitchen.